Hello, my name is Chaco Daniel. I'm a principal program manager in the hyperscale compute team in Azure. I'm here to talk to you about deploying and managing applications using Azure Service Fabric. So today, the agenda for today would be to give you an overview of Service Fabric. I'll go through the concepts and terminology, and then I'll go through how you manage your lifecycle of your service. I'll give you a view into the portal, how you can use it to deploy your clusters, and also then your services into it. I'll talk about a fault analysis service, which is a tool which we provide so that you can simulate faults which you have in production. And then the last I'll close with the monitoring and diagnostics aspects of our platform. So the very first thing is, in the past, as developers, we actually had the luxury of setting up monolith applications, and that would mean that basically it's not very easy to scale, deploy, manage, or even upgrade your applications. It actually takes a long time even to think about getting into a next train, which actually gets there in time for you to see it in, say, 2-3 weeks time. So in today's world, it is expected that your service stays up 365 days a year, 24/7. So that being the case, you have to now think about how to use microservices as an approach. So we need the ability to develop, test, manage, monitor, and diagnose services and fix these in real time, and all the same time add features to your service or your application without any downtime. The key about this one is to have your availability up all the time. You cannot afford availability loss in a critical, mission critical app service. So the architecture which you put in place on day one should actually be good enough so that it actually serves you well even after 5 years. So that is actually the design principle you want to start with, and that's why microservices actually is a right approach for you guys to use. And then also the key about microservice is that it actually allows you to also reduce the cogs you may have for running your application. So let me actually go think and show you as to how Azure Service Fabric helps you to do all these things. So quickly wanted to just go over the two pieces which I just talked about. Basically, monolith application approach. Basically, it is the way you would scale monolith application is basically creating multiple replicas of or instances of each of the applications whenever you want to scale. So you will have multiple tiers. Basically, you would have a front end, back end, and maybe a middle tier. And then whenever you want to scale, as I said, basically you create multiple copies of the same. So basically, you as you can see, there's impact to your cogs at that point, because the only way to scale is to make multiple copies of the whole application. So now let's contrast that with microservices application approach. So there, what specifically happens is you're actually dividing your application into multiple services. So each of these services actually are a scenario by itself. And so the way you would scale this is actually creating multiple instances of this service, each of these services. So for example, if you need this red hexagon is what you want more of, you just basically deploy more of those. And each of these microservices, since they are versioned separately, since they are also having its own code and config, you can actually upgrade them independently of each other, roll them out separately, and do not have to wait for a long train, which you typically had to do when you were doing monolith applications. So in this new world where agility and on-demand scaling is a must, this is the right model to approach it. And then Service Fabric is the platform which you can use to do that. So let's recap as to what a microservice is. So microservice applications are composed of small, independently versioned and scalable services that actually communicate to each other using some standard protocol. It could be HTTP, it could be TCP, or UDP, whatever else that makes sense to you guys. So you can use any kind of communication mechanism. So for example, what would be a good example of a microservice? So for example, for a online retailer, it could be a shopping cart, it could be an authentication module, an inventory module, and each of these microservices encompasses one complete scenario. That actually is the key. So so each of these microservices basically are typically developed by a small engineering team, so they are pretty agile about what can be added to it, what even fixes made to it, and then roll it out. So that's the key here about it. So this particular team also owns the code and the config and the data, which actually constitutes the complete microservice. So that actually is the reason why it's pretty agile, and that's a way to do new cloud native applications. And each of these microservices do not have to be written in the same language or the framework either. It can be one microservice can be written in any language, another one can be on a different one. So that actually is one of the key properties of a microservice. So then the other one is each of these microservices are absolutely talk to each other, communicate over well-defined interfaces and protocols, which I just talked about. The last two bullet points are very key here. So the two other properties of microservice is that each of these have unique names or URLs that can be addressed and resolved. That is the key. So each of these have unique names in a particular deployment. Then in spite of all the failures of infrastructure or even its own replicas, the state needs to be consistent and available in the presence of failures. That actually is the key to calling a microservice. So let's just now talk to you about Microsoft Service Fabric, and as to why that is a platform which allows you to do all these with ease. So let me quickly give you a quick overview of the platform. Microsoft Azure Service Fabric has been a key ingredient which took tier 1 applications like SQL Azure, SQL Server, Link, and then transferred them into cloud native applications. So this particular platform is a proven platform, which basically makes it easy to build scalable and reliable microservice based applications, allow you to keep compute and associated state together. So that's key. You don't really need a external database which you need to transact against. You actually can do it locally next to the compute itself. So that actually reduces the throughput. So actually increases the throughput and reduces the latency. And then this platform also allows you to do full lifecycle management. That is key. So basically, you can deploy, scale, monitor, diagnose, troubleshoot, upgrade your applications without downtime. The key being without downtime. So basically, you don't need another set of machines on which you do whip swaps with. Whip swap is not something which you need to do at all. Basically, it's an application which is there. You can upgrade with no downtime. The last one of the key things about this Azure Service Fabric is that you can actually develop and test your application on a dev environment, which actually is a full fidelity environment, which is exactly what you would find in production. So basically, the way you can do a lot of testing locally on your one box and then deploy them into cloud, whether you want to do it on Azure or your cloud which you form on-prem, or take it to our competitors like, for example, AWS. So it's a choice you can make. And then the other thing, which is the lifecycle management. So for example, SQL Azure is one of the biggest deployments which we have on Azure Service Fabric today. So they actually have they kick off multiple and many application upgrades at the same time, in the orders of 40,000 applications at the same time. And this particular platform is able to handle it with ease. So this is a trusted platform which we have internally used in Microsoft, and it's available to you to use as well. So let me just now go focus back into what this particular talk was about. So this talk is about management capabilities. So what are the management capabilities will you need when you have a application that needs to stay up 24/7, 365 days a year? So one of those things absolutely you will need is a reliable optics into what's going on in your service at all times. You will need to know if there are some partitions which are running hot. Are there enough of CPUs and RAM left on your infrastructure? If not, can you scale it out? Can you scale up or down based on service demands? You also need to understand if there is an issue which is going to happen or is happening. You need to get alerted. You need to have a robust notification system. You need to have tools which actually allow you to test your service in production, maybe in a smaller scale. It also simulate conditions before it happens in real life, so that you can have your applications survive those things, and your services can be made resilient against those. So that's something which Azure Service Fabric provides. And then the last thing which you also want is basically an easy way to deploy, test, and upgrade your applications, whether it is just basically the code upgrades you want to do, or just the config upgrades, and this should be done independently of each other or together without downtime. So that actually is the key Service Fabric platform capabilities which you get right out of the bat without doing any much work. So before we get into the detail to some of the demos which I will show, let me define you a couple of key concepts. The very first one is the Service Fabric cluster itself. So Service Fabric cluster basically is a set of machines, whether it could be physical machines, virtual machines, and these machines basically get stitched together to form a reliable and a fault tolerant and highly scalable unit, and this unit is called a cluster. So in Azure, for example, we are able to query the topology on which all these VMs are, and then form a cluster based on the topology of these machines. So if you're doing this on-prem, basically you would have a manifest where you would actually talk about the fact that, okay, this particular machine happens to be on this particular TOR and this rack. So this is something which we get for free in Azure, and you don't have to specify it. If you take it to any other cloud provider, there is actually a manifest called cluster manifest which you have to provide, and then we will stitch the cluster for you based on that. So there are two concepts which you see on your slide out here. So one is the fault domains and then upgrade domains. Fault domains basically are the physical characteristics of that machine itself. So the physical characteristics could be that this machine is in rack 1, and it actually is on this subnet which is coming in. So that could be and then they are logically named as FD1, FD2, FD3, and so forth. And then UDs, they're called upgrade domains. Basically, those actually are the units of our units of planned downtime. So these are the ones which we will use for upgrades, since we do upgrades UD by UD. So that actually is important. And this is something which in Azure, as I said, we get for free. But on-prem, you just basically get to decide how many number of UDs you need in this cluster. Now let's talk about the scale of these clusters. So the scale, so you can start from a minimum of 5 and go all the way up to thousands of machines. So there are SQL Azure clusters where they are in the thousands of machines which they run, and then they're also can be upgraded without downtime at all. And then we can do the fabric upgrades behind the scenes, and the application upgrades are done by you guys. So that's something you can do. The other characteristic of this cluster would be that if you want to think in terms of fault tolerance, you could actually also put a set of these in different data centers. So for example, Bing Cortana, which is one of our services which run on Service Fabric, actually has clusters which span 3 geo data centers. In that way, if one of them dies, the Cortana service itself doesn't get impacted. So these are the things which you can consider when you are deploying a cluster. So let's just now quickly go into what an application and what a service is. A service is made of code and config. Together they form a service, and multiple services make an application. That actually is our logical concept. So the way to think about packages is basically service package actually is a unit of deployment and activation. So the key here is, since the service package is the unit of deployment and activation, that is the unit of what you can actually make changes to. You don't need to rev the whole application package. Application package basically is just the lifetime versioning and isolation boundary. So this isolation boundary you can choose to do in a container as well. So since this new world containers are important, you can actually say this particular service type runs in this container. This container, as of today, it could be Windows containers. Later on, we would actually have some support for Linux containers and so forth. So service fabric, service type A and service type B doesn't have to be the same kind. It could be of different sizes. They could be revved differently. They can be versioned differently. That is the key here. So the keys to remember: one, unit of deployment and activation happens to be the service package. The unit of lifetime versioning and isolation is the application package. Each of these service types have a strongly typed name, which actually would be I'll give you examples of it in the next slide. So the last piece of it is thinking in terms of, now that I have an application defined, how do I instantiate a copy of that? So basically all your, so for example in this scenario there is an application 4 and then there is a type service type A and then application 4 type service type B. So Service Fabric, based on the topology of the cluster itself, can figure out as to where these replicas would be. In this scenario I've said that I need 3 copies of the red hexagon and then 3 copies of the yellow hexagon. So as you can see, it actually got spread out over so that all of the cluster nodes are used, and we will start to reuse them for placing more replicas if there's a need for it. So each of the service instances has a unique name in the namespace of the application. That's the key. So for example, in an inventory, so in a ticketing system, you can have a airline schedule service, a inventory service, a payment service, a printing service. All these together form actually a airline scheduling service. So that's a way we could think about it. So the other way to think about it, of course, is the fact that we can do a comparison to types. So service type is very, very close in terms of concepts to a type in Java or .NET. Each of these instances, as I was talking about, like for example, if the application happens to be Fabric ticketing, then the schedule service happens to be one of the services. Inventory service just actually is a part of the URL, which happens to be for the address for this particular service. So let me show you a demo at this point. So what I'll do is I'll actually go to the portal, which is available today, and then create a cluster for you. Since all our clusters are described as an ARM template, the Azure Resource Manager template, I'll actually go through the resource template as well, and then after that I'll actually try to deploy an application for you. Okay, so you sign into the portal. Create new. Search the marketplace for Fabric. There it is. Then press create. So this particular journey you will go through has actually 4 steps. The very first thing is to name your cluster. So you can call this like in this scenario I'll just call it build demo 03. And then this basically is, let me just expand this a little bit. Control plus. Okay. So this basically is these 3 questions here is to do with RDP to your VMs, which you would be having in your machine in your cluster. Then the next thing is to figure out as to what subscription you want to use. I have a lot of subscriptions. In this particular one, I'm just going to use build demo. And then here it is, unless you are going to reuse a resource group, it's preferred that you create a new resource group. In that way, it's easier to delete this cluster by just deleting the resource group. So it's a choice you can make in case you have an application which needs not only the Service Fabric cluster but also has a website which is outside and so forth. So then you can use a resource group. So the location happens to be West US, and then now it's time to now think in terms of how many, what kind of characteristics do you want your cluster to have. For example, if your application has a front end set of machines which needs to be facing the internet, and then there is a backend which is just purely compute. At that point, you would choose to say I have two node types, or like two node types. So when there are two node types, basically what you are doing here is you go into the first one, which happens to be what we call the primary node types. The simple thing about primary node type is that is where all our system services live. System services in a nutshell are basically the services which Service Fabric itself owns, and it actually runs in your cluster to manage it. That's what this thing is all about. So let me just say that this is the backend node type. I can choose the VM size which I need. We allow for any standard VM which Azure offers. So in this scenario, I don't want a D4. D4 is what we default to. I like to just use a D2 because I'm not planning to use it for production services in this particular example. You can actually just for demos, so I'm just going to do D2. You can choose to select any of the VMs which you would need. And in terms of how large should this backend be is the slider. The minimum you can choose happens to be 5, so we'll leave it at 5. So this is the only node type which is called the primary node type where there's a minimum of 5. The other node types can be 2, 1, whatever else you may need. And then the last one is, so if I want a port to be open on this backend, then I just give the port number. And then I don't have a placement property which I'm going to do, and then I don't have a capacity. So this capacity, maybe I should just say that okay, my RAM happens to be 512. So this is something which you can now specify as a node property to Service Fabric, so that now it can use that when you report load for placement of your replicas. So that's what that particular hint is for. So node type 2. Node type 2 is let's say it's a front end. I certainly don't need a D4 for it because that's a very large machine. So let me just go select a smaller one, maybe a D1, and then I don't need 5 of them. I'm going to do 3 of them, and then on the front end I need a couple of ports open, say 8080, and if I'm going to deploy one of our samples, then I would like to have 808081. And then the port 80 has to be opened. So then for capacity, I can say this particular RAM happens, or I mean, it doesn't have to be. This name can be anything which you want to specify as a property. In this case, I'm just going to use this as RAM, as one of the names. So it doesn't have to be the exact RAM of that particular VM. So that's what I'm trying to say. It is totally up to you as to how you report load. The next things which is important here is as a default we actually turn on diagnostics. There's a lot of diagnostics which we from the system services pump out using ETW, and into one of your Xstore locations, and that's what this one is for. And then if for advanced users, basically you can also specify some of the other Fabric properties, and today I will not go into those. Security. So if we highly recommend that all your clusters be secure. So the security, basically, if you're setting up a secure cluster, you're expected to upload your certificates to a key vault, and then basically give a certificate URL out here of where in the key vault is your particular thumbprint, and that's what this one is about. So we also allow you to specify 2 certificates, a primary certificate and a secondary certificate. The reason for the secondary certificate is basically it allows you to have certificates which expire at different times. And so in that way you can roll over certs, and that's one of the reasons why you have this. When you're first creating it, you don't really need 2 of them. You can just start with 1. Then if you're one of those customers who actually has a lot of people who need read-only access to your cluster, then you give them multiple thumbprints. You can give multiple thumbprints here, and then the admin, and then if there are users, say for example operators who need admin access to it, who can actually deploy applications to it, then you give them that certificate. So for this particular demo, I'm just going to do unsecure, and the key here is we will not be able to change a unsecure cluster to a secure cluster once it's set up. So this is a big choice you have to make, whether it's a test cluster and so unsecure is fine. If it's a production one, certainly never do a unsecure cluster. So at this point, it actually gives you a summary of what happened here. So it just says that it gives you a summary. You can just do OK. If you want to download the template it just created behind the scenes, then that's something you can do as well. So I just say OK. So let me just go through the ARM template it's actually generated, just so that you guys see that how many resources truly make up this particular resource called a cluster. So this is the ARM template, which actually is a seven node. It's very similar to what we created, and then it has 2 node types, very similar to what we just saw. So let's just look at the number of resources which this cluster uses. So very first one, of course, is there is a storage account which we use for storing the VMs. Sorry, let me bring it up. Then this is the storage account for storing logs. All these VMs are actually interconnected using a VNet, and that's a definition. This is the definition of the VNet itself. Each of these VMs have IP addresses, and this comes from this particular definition here. This is a network resource here. And then all these VMs, when we are requested for a port 80 to be open, for example, or for 8080 which was opened, they actually have a probe which is defined here, and then behind, and you would see the probe, and then inbound NAT rules are actually created for it, and then it also has load balancing rules for those probes. So these are the definitions you can see. I will not go into each of these. I'm just going through this so that you guys have a way to go and find this out. And then for each of the node types, basically we define a VM scale set. So every node type is equal to 1 VM scale set. So in this particular scenario, I should have 2 VM scale sets and the same set of resources I would use. So number 6, same again, the IP addresses, load balancers, and then the definition of a VM scale set. The very last resource happens to be the service fabric cluster. The provider for this cluster happens to be the service fabric. So in this, the properties, like for example the ones which we just saw, where we were defining the capacity, that those will show up in properties. So that's a quick overview of what this ARM template looks like. So let me go back to the portal for a second, and then let me use one of the clusters which I already had provisioned. Typically, a cluster provisioning takes around 10 or odd minutes. So since I don't have that much of time to wait for it, I'm just going to use one of them. So once you go there, here are the things which you're looking for. One, the key thing here is called the client connection endpoint. This is actually the way you would communicate to this cluster. So from an external client. And if it is a secure cluster, you also have to give the certificate and so that you can be authenticated. And that certificate has to be on your local box or your client before it can connect. The other one is called the Service Fabric Explorer. So that actually is a UI tool which you get out of the box. In this particular cluster, I have 3 applications which are deployed. First one, of course, is systems. This is for an empty cluster, you would get system services. So I will not get into these. Basically, the cluster manager, failover manager, image store service, naming service, and so forth. So one of the deep dives we can do later, I can just go through all these. So for today, I will not go through those. So then in this particular application, in this particular cluster, I have an application which I deployed. This is called Chaos Test. This application is a sample which you guys can go and download as a part of the SDK, or there are links from there to our sample Git repo which you can get this from. So basically, I will actually go through later on in this talk as to what this Chaos app does for you. The next one is actually a UI tool which I have, basically called the Cluster Monitor. This looks like this. Basically, I have what it just says is you can see all these replicas of my applications which I have deployed, and this will be one of the UIs which we'll use when I'm going to do some failovers and so forth for a demo. So a couple of things I want to highlight, and then I'll just get off this. Basically, is you can see that there are some health reports which you can see very clearly out here. One basically says there are 4 applications which actually are healthy, and then there are three states each of these applications or clusters can be at. So let's just, at every level you would see 3 statuses: 1 OK, warning, or error. So in this particular UI, we have said OK being green, warning is yellow, and error will be red. And then we report out of the box at health at every level. So let's just go and drill through one of them, and so in that way it's very clear. So at the cluster level, you saw there was a health state which is OK. This application says overall this application happens to be green, and then under this application I have 2 services, and so you would see that each of these service, the application health and then the service health are actually also shown here. And so basically what I wanted to show you is at all the 5 levels we have health reporting. At the cluster level, application level, service level, partition level, and the replicas, and at the replica level. So that being the case, you get to know you have a framework which you can tap into later. So we'll just talk about that when we get to the health state of each of these. So now that we have a cluster, so we are ready to talk about a couple of things. One, what kind of programming models are supported, and how can I use this cluster, this particular application framework, so that I can now start to use this robust platform which we just got introduced to. So you have 2 ways of doing it. One, for example, in a migration scenario where you're trying to move your monolith application to this microservice based architecture, so you can start to move small things at a time. So the very first thing which is supported is something called any code. This any code is basically means that you can actually deploy applications which you've written in Node.js and say it also uses MongoDB and hosts in Service Fabric. So that you can take advantage of the management capabilities of Service Fabric. But if you are now ready to dive into more details and then try to use the most like all the power of Service Fabric, then we provide you 2 programming models. One is called the reliable actors programming model, and then the reliable services programming model. So applications using these APIs provide Service Fabric deep insights into these services, and so allowing you to maximize the benefits of Service Fabric. The models so this basically allows these models allow the reliability of your code as well as state and all other benefits of the Service Fabric platform. Like for example, security, placement constraints, resource balancing, zero downtime upgrades, and then locally replicated stores, which actually gives you far more throughput than you can ever get when you're trying to reach out to a database which is outside. We also provide you Visual Studio templates so that you can actually get started quickly. And so let me show you how quick it is to use one of these programming models, and then what kind of robust tracing you get just out of the box. So let me just show that. All right, so let me start. Since I'm going to be running a debug on my Visual Studio, let me just start it as an administrator mode while it's coming up. File, new project. Under the cloud, you would see Service Fabric application. I've selected this. I can call it a demo app 22. Create. So out of the box, you can see that there are actually 5 types of templates which we support. There are 2 which are basically to do with reliable services and reliable actors. So in this particular scenario, I'm just going to say I'm going to now create a stateful application. So quickly, before we get into details of it, stateful just means from a Service Fabric angle just means that now you are now going to store the state of your application or your microservice locally with the compute on the node. That is stateful. Stateless from a Service Fabric angle just means that you are just using it for compute, and your authoritative state lays outside, or it has no state. So that's how you should think in terms of stateless and stateful. Stateful, it's going to create this application at this point. It gives you a template out of the box so that you can actually get this thing quickly running. This particular template actually gives you a running application to start with. This particular application basically is a counter application. So it derives from something called a stateful service. So you actually implement that particular class. And then in here, let me just close this a little bit here. So this is for the communication listeners which you have. And then as for people who have been familiar with cloud services, we're used to having a run method. Here you actually have a run async method. So because this is a distributed computing world, most of our calls are actually async. So that's what you're implementing. And if you step back and think about it, all it's trying to do is it actually is constantly adding value to the previous value and then just counting up. That's all it's doing. And then basically stuffing that particular value into a dictionary. That's all it's trying to do. And then it actually writes it out to writes it out, and so that's all it is. So let's just go and press F5. So I have a local cluster running here on my machine locally, and so it'll now compile and deploy it locally on my one box. So this particular laptop has a five node cluster running, so it actually emulates a production 5 node cluster. So you don't need to spend any money, and basically it does all these things for you. So if you now let's look at one of these. Let me pause debug for a moment, and now you can see that now our system services like failover manager is now saying that actually we have created a service called stateful application, and it is under demo 22. So fabric application name demo app 22 stateful 1 happens to be the service which is created. And then it actually goes on to the other system services, and then let's just continue on. So now it is attempting to deploy it, and so let's just go back here again. So the very first thing it did, okay, I don't have a current value, and so it queried the local dictionary and said I don't have it, so it starts from 0. So if you look at it, just basically running. So you have a running application at this point, and then this will continue to run even if I were to actually simulate a failure at this point. So quickly before going into too much details, I want to show you the local cluster which is running here. So this is the local cluster which I just deployed. So in this basically here, this is the app which we just deployed. It just says I actually have a stateful 1, and then it's running okay. So we'll not spend too much time on programming model at this point because this actually is a management demo. So let me close the things which I don't need and then go back to my PowerPoint at this point. All right, so let me step back now, walk you through what an upgrading of a service truly means, and then how does Service Fabric do that. So in this particular slide, I am actually having the same app 4. I had service. It actually had a service type A and a service type B. In B, actually, I had a yellow hexagon. Now I'm actually going to change it to green, and now I want it to be deployed. So the code change I've already made. It's ready to go at this point. Basically, anything which I showed you using the Visual Studio, you can do using PowerShell. So you can do in either one. If it's a production cluster, I would assume that you will want to have it operationalized, and so it will be using PowerShell so that you have audits as to what who ran it and so forth. So so basically, what I'm trying to say is what you can do using Visual Studio, you can do that and more using PowerShells, which actually is a part of our product anyways. So so let's just now kick off the upgrade. So it basically upgrades progresses 1 UD at a time, and then upgrade can be code, config, or both, and then it is limited basically to to the code package which changed. So in this application, although there are 2 service packages, the only things which are copied over and upgraded are the ones which got changed. So that is the key here. So each of these, during this upgrade, basically the system checks for the replica health, and if the health policies are not met for some reason, then basically the upgrade just stops and rolls back, so that you don't have any loss of availability, and then you actually have traces which you can just go in and look and see as to what really happened. So the key here is at no point is there is the service availability getting lost. So now let me show you a no downtime upgrade. Before I go to the demo, so this demo actually is using a application called Visual Objects. That's what we call it. Basically, it is nothing but a number of objects, which are triangular objects, which are actually bouncing around. That's what it's supposed to be doing. And I have it deployed onto one of the clusters. So basically, if you look at it, each of these colored triangles are actually different services which we have deployed, instances of the services which we have deployed, and then the tail of these particular triangles is basically the last 10 locations of where this particular triangle has been. So that actually is the state for this particular sample. This sample is available to be downloaded on the GitHub as well, so you guys can see this particular sample. So today I will not get into the specificity of all these samples. So, but I want to go through two things which we had learned. One is the application and the service itself. So for those, basically we have them described in application manifest and the service manifest. So in this particular application manifest, basically there are 2 services. One is the Visual Objects actor service, and then there is a web service which paints it. So this web service was created using paper.js, and it doesn't really so anyway, so and then this particular actor service happens to be a stateful actor service which we have running. So now let's look at the application service manifest for each of these. So this web service actually has a service manifest which actually has version 1.0. Application here also was 1.0. Let me just show you. So that was the version. So each of these application and the services are independently versioned. And then here's our stateful service. Basically, it has a code and a config version. So in this particular scenario, what I'm wanting to do basically is this. So I want to add a rotation to this particular triangle, so that now instead of just going straight the way it is doing now, it will also start to rotate. So I'll just start to move. Let me just do that, compile and deploy. So before I deploy, there is another thing which I want to show you. So from the Visual Studio, you can deploy locally or right to the portal which we just saw. So my cluster out there happens to be this. So if you look at this, this is my cluster endpoint, client connection endpoint. It's just to be called build demo, and then it has a port 19,000. So I just edit the cloud.xml and then indicate to Visual Studio that that's where it needs to deploy. Save it, and then I just go find my application, right click it, say publish. So a couple of things which we have to do before we publish. One, basically we want to give this particular service which I just changed a new version. So the one which I changed was this particular actor service here. So let me just change this. So basically, as you can see, as soon as I change my service version, the application version also changed because I had put a tick here. The format of the versioning itself is totally up to you. This particular thing happens to use semantic versioning, so it's something which you can choose to do what makes sense to your deployment. So from there, all I'm doing is publish. So when I publish it, it compiles it, it reaches out So let me just also monitor it while it's coming up here. So the very first thing it will do, let me get this, yeah. So here's the application, with Visual Studio, Visual Objects application. This one. And so at this point there is only one version of this particular type here. And you will see that the very first thing it will do is basically register a new type. If it's gone through, let me see what's going on here. Oh, so looks like its upgrade is in progress. So let's just go watch it on the other side. So where was this? It was here. So at this point, I should be able to see that, okay, here it is. Here's a new version which is running. It's on the same cluster which we saw before. And then at this point, we would like to watch it. Let me now talk to you about monitoring and monitoring your services, and then we'll just get into diagnostics, and then we can actually talk about a tool which we have, which we can use for simulating failures in your test environment or even in your production environment. We can simulate failures so that your application can be made more robust. So when I think about monitoring, so I always think in terms of like if you're running a service in production, it is critical that you have visibility into your application and how the services are doing. I categorize them into three pieces: performance and stress response, service health status, collection of telemetry for your service, so that you can actually know as to what really happened. For performance monitoring, basically we emit like metrics for both the programming models. You saw when we press F5, there was lots and lots of detailed metrics which we do. Then you can actually combine those with something which you write for yourself. For example, the one which you just saw, the counter value was being written out. So it's not restricted to what you write out. It's totally up to you as to what you write out for your service. And then the second thing is you can also use these particular performance monitoring metrics and then pump it into any of your tools which you want to use. So since we use ETW, that's actually standard. You can use any tool of your choice to consume and visualize that. The second piece of it was the health status monitoring. So there is a built-in health report, health model which you get, which I talked about earlier. And then there are health reports which the system services provide for your cluster and also for your applications and our system, and also our system services. So you can also, since this particular health model is actually extensible, you can actually start to report your own health statuses for your services, applications, replicas, partitions, and then make it more informative to what you want to do. And then since this particular framework, this particular health framework is used also for all our operations internally, for example, the fabric upgrades or your application upgrades, you actually now have input into how we perform and evaluate our health based on all the health input you may provide. The last one is business telemetry. So business telemetry, like in this day and age where every decision is data driven, having the ability for you to collect, analyze, and drive insights into your customer interaction with your application is key. And then our systems, the service fabric provides you this capability so that you can plug in your own telemetry and then pump it out. So moving on to the next piece of your puzzle, basically is, now that you have your application running in production, one of those key things which a lot of customers ask me is, what is the diagnostics and what troubleshooting capabilities does Service Fabric provide? So I've divided this into three pieces. One is detailed system optics. This actually allows you to know as to what Service Fabric itself was doing when something happened to your application or your service, so that you have the complete picture. This helps you to guide you on how to fix this issue. For example, System Optics actually talks about it actually gives you the tracing of all the important system events, like for example, application service deployments. Here is when the upgrade started. Here is when the actors got created. Here is when a replica got placed. Here is when the partition got created, your save, your load state calls, and so forth. So it also, in addition to all these, if you're using our programming models, it actually even tells you that, okay, you're actually, your run async calls were actually very slow, and so forth. Then the second thing which the platform allows you is the custom application tracing. As I was saying earlier, you can actually add on to your to the system traces your own application traces, and then you can have a complete holistic understanding of how to troubleshoot a problem. Since we use ETW, of course, the custom tracing code that you write works on your local dev box when you're deploying, and then also the same code can be deployed onto the cloud, and then it works there. You don't even have to rewrite anything. And the last bit of very important choice is you may already have tools like Elasticsearch, Kibana, Elk, so you can use those tools to read ETW. So all these traces, without even doing anything different or investing in a new tool, you actually can do diagnostics and troubleshooting. So let me do a small demo. Yeah, so now the upgrades are already completed. So let me just do a couple of things which are interesting. So we'll watch a couple of things here. So now that now that we see that this particular application, let's just go do some simulated failures on here. So for example, this particular partition is running on, say, a node called frontend 4. And so let me just go into the nodes, frontend 4. You can actually now let's go and say deactivate this node. So basically we are now simulating if a failure where that particular node just went down. So it just went down. So if you look at my cluster monitor out here, let me just get, where is FE4. So you should watch this particular column, and then you can see that this particular, so basically you can see that all of them turned red. So health status for each of these replicas now became red, saying that it's actually down, and it's basically the whole node has gone down. And you still see that none of my 10 actors out here actually had any blip at all. Although you did see that there actually I had a service running on it. So now let's go back to the same service here, this particular actor, and so it's actually failed over to the node number 3. So this is something which happened without you trying to do anything at all. So this is something which you get out of the box. So now I did this manually. So what will be more interesting is, does Service Fabric provide you an application which you can use to simulate this condition where you're losing nodes, we are trying to get some of your replicas going down at random. So we do have a service which we provide, and then there's a sample which you have which you can deploy. We call it the chaos test. So let me just first now activate that particular node, so that's something which we don't need down. So this particular service I have deployed, this particular chaos test app is something which I deployed to this cluster already, and you can get this from our GitHub account, and then you can do that as well. So this particular chaos test actually has a front end, so that you can just say, okay, let me start the faults. So the reason I have left this bouncing, okay, so now it started. There's bouncing triangles on the side, so that you can see that although this particular chaos test has started to run, it's now starting. Now the very first thing it does is ensuring that the cluster is healthy. So it's just going to do that and start to introduce faults. And you should not see this particular application losing any of its state or stop bouncing. That's the key. So it looks like it is still waiting. So it does that for you. So for the sake of time, I'm going to move on. So call to action. So now that we have reached, I've gone through the whole platform, which talks about the fact that we give you out of the box ability to deploy, manage, monitor, and have rich tooling to simulate application failures, application deployments, and also cluster node failures and so forth. Now so I will want you guys to go try it out. So very first thing is go download this SDK, learn from our tutorials, give us feedback. This actually is the first time we're going GA with this product for the whole wide world to use. So certainly there may be things which we need to improve. So basically we do need your feedback. You can actually either use the Service Fabric forum, that's aka.ms/Service Fabric forum, or you can go to Stack Overflow. There is Azure Service Fabric tag out there. Create an Azure cluster at portal.azure.com, and then tweet using our hashtag. Thank you for the time. Do try out our SDK today. We do need your feedback. Thank you so much.